Yep, indeed.
Oh,
All
okay.
right, let us pray. In nomine Patris, et Filii, et Spiritus Sancti. Amen. Memorare, opissima Virgo Maria, a seculo non esse auditum, quemquam ad tua correntem presidio, tua implorantem auxilia, tua petentem suffragia, esse derelictum. Ego tali animatus confidentia, ad te, Virgo Virgine, Mater, curo ad te venium. Coram te gemens peccator sistem, noli mater vergine, verba mea despicere, sed audi propitia et exaudi. Amen. In nomine Patris et Filii et Spiritus Sancti. Take out please your practice test version 2, or version B, I forgot what I called it. And let's run through some answers, and then the rest of the hour we're going to dissect it. So, looking at something big enough that I can actually see without glasses. There we go. Double check for me. Does everybody have your practice test on? Can somebody confirm, is f of x x squared plus 5x plus 2? Good, we have the same version. All right, here we go. Number 1. F of g of x should be 4x squared plus 14x plus 8. 4x squared plus 14x plus 8. Number 2. Do something actually on screen. Hi for everybody at home.
Hello. Hi.
Number 2. Number 2. Simplified version. They do want you to get a common denominator. Number 2. It's a fraction. The top is 2x plus 5. The bottom is 5. You can also leave it as 2/5 x plus 1 if you absolutely wanted to. Number 3. It's a big fraction. The top is x squared plus 5x plus 2. The bottom is 5. Number 4. 2x squared plus 10x plus 5. And it repeats up to, yeah.
Could you repeat number 3?
3, yeah. The top is x squared plus 5x plus 2. And the bottom is 5. Any other repeats on the first page? Yeah.
I just want to repeat. What if we just like did 1/5 x squared plus x?
X squared plus, say again?
1/5 x squared plus x plus 2.
Oh, if you divided it out, 1/5 x squared plus 1x plus 2/5, I would accept that.
Okay.
That's good. Any other repeats or quick questions for first page? All right, next page. Number 5, describe the transformations necessary. First, flip it upside down. Second, 3 times taller. And they don't have to be in that order. Number 6, there are 3 changes. Flip it upside down, make it 1/3 as tall, and flip it left to right. See the negative in the input?
If you said 3 times shorter.
I'll accept that, sure, that works. Everybody okay on number 6? Number 7, the parent graph, I might as well just write this. The parent graph is x squared. Any parabola is going to be based on x squared. You didn't really have to write that, but the final answer, I just put y equals, you can do g of x equals. It should be 1/3 x squared plus 2. Okay. That's for number 7. How about?
Is it -2?
Ah! Thank you. I did plus, I had the opposite, I bet. And I forgot the opposite. Number 8. It is y equals,
What was the equation for number 7?
sorry?
What was the equation for number 7, the not parent function one?
This,
Oh,
that's it. So, x minus, the parent function is x squared. That's the stripped down version.
okay.
x minus 1 parentheses squared minus 3, or plus negative 3. All right, fine, I'll change this to minus. Either way, it's fine. Maybe okay on number 8? Number 9, transform and write the resulting function. I might as well just write this. Y equals 1/3 parentheses x plus 3 quantity cubed. I'll get this other way too. And number 10, you should have y equals negative x cubed plus 3. Again, take whatever function they give you and just modify it. So you don't have to come up with a brand new function. Number 11, I'll put over here. Find the inverse. 2 ways you could write this. Actually 3. Maybe 2. I've got, this is the version I had. It was it was G inverse. Please do start it with that. G inverse of n, which is, n is a weird function input, but it's their problem. They can do what they want. I had n minus 1 over 2. You could also have, although it's a little weird, negative n plus 1 over negative 2. Oh, wait a minute. This is backwards. Holy mother of pearl.
I was a little confused when I asked.
For those of you listening at home, maybe you can just rewind and then watch me mess up again. This should be 2 over n minus 1. And the other one version is negative 2 over negative n plus 1. Either of those would be fine. Why I was looking upside down at that, I have no idea. That was just a brain freeze. I can't even blame the computer on that one. Next one, number 12. G inverse of x is equal to, I had 5x minus 15 over negative 8. You could also have negative 5x plus 15 over regular 8. There's one other version, negative 5/8 x plus 15 over 8. Any of those 3 would be fine. Okay. Number 13, the inverse is as follows. I had x minus 5, whoops, sorry, G inverse. X minus 5 over negative 7. You could also have negative x plus 5 over regular 7. Or if you want to be exotic, negative 1/7 x plus 5/7. Any of those 3 would be legit. Okay. Number 14, there's really only one option for this one. It is f inverse of x, ladies. Negative 2x cubed. I did, in fact, say that. That doesn't mean for 2 seconds only. Negative 2x cubed minus 3. Okay? Number 15, does everybody good on 7, 8, 9, and 10? Anybody need these still? I need a little more. I'm only going to use the middle thing because we're recording. So I get the space. I'm going to scoot this out of the way a little bit. Find the inverse of them. So you have to find basically 3 things. Find the inverse equation, then graph the original, then graph the inverse. So it looks like this. For number 15, the original function is f of x equals negative 5/3 x plus 5. The inverse function should look like this. A couple of versions. Negative 3/5 x plus 3. There are some other versions of this. They may have a different version they want to check out. One I know off the top of my head is negative 3x plus 15 over 5. That would work as well. Okay. Now to graph these things, the first one's not too bad to graph. Y-intercept of 5. And then you rise negative 5 and run 3 to the right. So there's your first one, that's F. Then F inverse, graph this, you go up 3, I'll do open dots for these. Then we're going to go down 3, to the right 5. I wouldn't really graph this with a dotted line in real life. You could do it on the test. Just if I were on the job, I wouldn't do that. Because a dotted line means, like, that's when you actually have less thans or greater thans, and you're shading. So I'm just doing dotted line for it because I don't have multicolors here. If I were like in a corporate room, I'd do this is green and this is blue or something like that. And then this is the F inverse graph. Does that make sense? Again, 2 ways to graph an inverse. You could get the formula and graph it straight away, or you could graph the original one and then flip all the x's and y's. And it does work. This is like 3 comma 0, it becomes 0 comma 3. This is 0 comma 5, it becomes 5 comma 0. Works like a charm. So whichever one you think is easiest, feel free. Every kind number 15? 16. Yeah, it's fun. It's a big fraction. The top is 4x squared plus 54x plus 76, and the bottom is 25. Can you repeat something? Extra credit number 17. State if the given functions are inverses and prove your answer. The answer is yes, they are inverses. 3 methods. You can plug one into the other and the other into the one and see if they both canceled x. That's method 1. Do the double plug-in to each other. Method 2, start with f of n and get its inverse and see if it looks right. Or you could start with g of n and take its inverse and see if the other one looks right. So if you take the inverse, it should look like the other one after you simplify it. Simplifying it might be a pain in the neck, but they are in fact inverses. Number 18, I gotta graph that thing. It's a little exotic. The only way we know how to graph that, does anybody need 11 through 14? Anybody still working on those? Okay. For those of you listening at home, just hit rewind. You have power over time and space that we do not. So 18, I'm about to sneeze because I just uncapped a new marker. Darn it. Hate that. Okay, I'm going to sneeze in the next 45 seconds, so please excuse me. X minus 2 cubed plus 2. There you go. Thank you. There it is. X minus 2, yeah. Plus 2. The only way I know how to graph this thing, as far as we know anyway, although next semester we're actually going to cover a way to graph this straight away, is to do a table. And I've got, they went from -6 to 6. A lot of these are going to be off screen, so you can just ignore those. You know what I mean? Off the paper. So, cranking these out, it's going to be -6 minus 2 cubed plus 2. That's enormous. This is going to be -8 cubed. 64. It's -512 plus 2, which is insane. There's no way, unless you just attach like 8 separate sheets below it, you're not going to graph that. -5 minus 2 cubed plus 2. That's -7 cubed. 340, -343. What am I doing? At any rate, it's too big. Well, too small. So -341. Not graphing that one. -4 minus 2. I get the idea that we're not going to graph this for a while. This is 6 cubed, which is -216, plus 2, which is -214. Still way too big. -3. I pretty sure is not going to work. This is going to be negative 125 plus 2, which is negative 123, still enormous. Negative 2. So negative 4 cubed plus 2, which is negative 64. This is getting better. Bless you. Bless you. I said bless you plus 2. Wow. That makes no sense. Negative 62, still too big. Negative 2 minus, whoops, negative 1 minus 2. So it's negative 3 cubed, which is negative 27 plus 2. That's negative 25. That's getting in the ballpark. Still big. 0 minus 2 cubed plus 2. That's negative 8 plus 2, which is negative 6. We're finally in business. This next one, 1 minus 2 cubed plus 2. I know this is like watching paint peel. I know it's totally exciting, but just humor me on this. I'm mainly doing all of these for the people at home, but humor me. So this is going to be minus 1 cubed, which is negative 1 plus 2, which is positive 1. That's a good grapher. 2 minus 2 cubed plus 2, which is 0 plus 2, which is 2. That's a good one. 3 minus 2 cubed plus 2, which is 1 plus 2 is 3. That's a good one. 4 minus 2 cubed plus 2, so that's 8 plus 2, which is 10. You can do that one. I'm going to put like a flat face on that one. It didn't go out to 10, but you can put a couple extra dashes. That's probably where I'm going to cut it off, because these are going to start getting really big. This is going to be 5 minus 2 is 3 is 20. This is like 29. And this is like 3 to 20. Oh, hang on a second. And then 6, and so 4, 64, 66. Those are too big. So what does it look like? Remember, we're graphing the original. We're graphing this. We're not graphing F inverse yet. So I'll start here, 0, negative 6, which is actually on screen, on the paper. Then 1, 1. Then 2, 0. Wait a minute. Something's a little weird on this. Negative 1, 2. 6, 1, 1. 2, oh, that shouldn't be. What in the world? Oh, there should be, yeah, 0. Wow. 0 plus 2 is not 0. It's 2. So, I knew that. I said the graph is not supposed to be doing that. Then 3, 3. And then 4, 10. I just put some extra. This was the top of the graph, and I just put 4 extra spaces here. It's optional. So here's what the graph looks like. It actually kind of flattens out and swerves. You might actually recognize that as a triple root. So it flattens out and then keeps going up. It's a triple root that they happen to move somewhere else on the graph. So how do you get the graph of the inverse? Well, this is 0, negative 6. So the mirror image, negative 6, 0. This is 1, 1. Congratulations, it's 1, 1. This is 2, 2. Congratulations, it's 2, 2. 3, 3 stays put. 4, 10 becomes 7, 8, 9, 10, 10, 4. And the graph looks like this. Does that make sense? They did also want you to find the equation, which I'll do down here. Start with y equals x minus 2 cubed plus 2. And then swap. Whoops. So you have x equals y minus 2, please, keep it down. And then get y by itself. First, subtract 2. So x minus 2 equals y minus 2 cubed. The way to get the cube out of the way, cube root both sides. Cancel, cancel. So the cube root of x minus 2 is equal to y minus 2. And add 2 to both sides. I'm just going to put that in front. So your inverse function, f of inverse of x, is equal to 2 plus cube root of x minus 2. Does that make sense? Any questions? That is number 18. That was extra credit. But there's going to be a very similar problem on the real test. So. And I think that's all I have. So, yeah, sorry it took so long. I meant the explanation was included in the answer itself. It just would have taken too long to do it otherwise. Repeats. Yeah.
So the symmetries, is that going to be on the actual test because there was only on one of these?
Yes. Holy mackerel, wait, what? Oh. One of the pages didn't print.
That's what I so
Welcome to my life. They are going to be on the actual test. I can go through, I can make up problems, and we can go through a couple of those today. Yeah, wow. On behalf of technology everywhere, I apologize. That was awkward. So, questions? First, so any questions on the ones that are on the test itself, and then I'll do a couple of symmetry problems. Okay. Number one, Stefan. Okay. Is everybody okay on the stuff on the board? I'll leave the chart there for a second for the extra credit for 17 or 18. Here we go. F of g of x. Is it f of x? Is x squared plus 5x plus 2? G of x is equal to 2x plus 1. There are people asking questions that need to be able to hear. H of x is equal to x over 5. And they want f of g of x. The secret of these is called a composite function, which means you put one inside another. Find out what the main function is, it's f, and find out what you're plugging in. You're plugging in g of x. Question, what does f do to its inputs? Short answer, it squares it, then multiplies by 5, and adds 2. That's exactly what we're going to do. Something squared plus 5 times something plus 2. I do that right away. Whenever I have a function inside a function, I take the main function and set it up. Then, what are we plugging in? G of x. Now, at this point, all I have to do is simplify. What is g of x? It's 2x plus 1. So it's 2x plus 1 parentheses squared plus 5 times 2x plus 1 plus 2. Be cautious. Order of operations needs to be obeyed. Exponents before multiply. This is not, please, I'm going to go down on bended knee, put my hand to my heart and beg you, please, for the love of all that is holy, do not go first thing squared, second thing squared. It is not 4x squared plus 1. It is not. I would love that error to be crushed and die a horrible death forever and ever. Amen. It is square the first, double the product, square the last. Square the first, double the product, square the last. Another mistake people sometimes make, they square the first and then they put 2x squared. Make sure you square the entire first. 2x times 2x, 4x squared. Now you can distribute this thing. That becomes 10x plus 5, and then plus 2. Now just gather the like terms. So 4x squared is alone, plus 14x, and then these 3, plus 8. Does that make sense? Next, go.
Why is number 9? Why is the height multiplier 1/3?
Let me learn. When it says compress vertically by a factor of 3, compress, does that mean make bigger or smaller? In general. Made it smaller. So the height is gonna get smaller. So instead, if you multiply the height by 3, it's gonna get 3 times taller. So you could either divide by 3 or multiply by 1/3. Either one would be fine, by the way. If you had x plus 3 parentheses cubed all divided by 3, I would accept it. So if you did, that's right. Does that make sense?
Yeah.
Okay, next. Yeah, good.
Could you do number 7?
Number 7, yeah. Is everybody okay on extra credit thingy? If otherwise, just watch YouTube tonight. I mean, watch my channel on YouTube on this video tonight. Let me be more specific. Watching cat videos is wonderful, but I don't think it'll help. Okay, if you absolutely need a study break, go ahead and watch cat videos, but then, okay. So number, I'm sorry, 7?
Yes.
Okay. 7 was, yes. The graph they gave us started at 2 spaces down. And if you look carefully, there are lots of points that are not exact, like they're in the middle of it, of nowhere. But there are 2 points that are good, 3, 1. And negative 3, 1. There may be some good points beyond that, but over 1, I have no clue. Like normally the pattern is over 1 up 1, over 2 up 4, over 3 up 9. They didn't do that. They went over 3, that's the first one they gave us. And up 3. What do you normally do when you go over 3? Done. Go up 9. Normally we go up 9. What fraction of that did we actually use? Go ahead. What fraction is this? It's 1/3. So it's 1/3 as all. So I know we're going to go from y equals x squared to y equals 1/3 x squared. Then the only other thing we have to do is move the graph down 2 spaces because it normally starts at 0, 0. And that'd be it. Does that make sense? Next. You can get, yeah, go.
Could you do number 6?
6, let me look. Yes. So if they gave you, this is number 6, f of x is just radical x. Again, they could give you any weird function at all, and then just look at how they modify it. You don't have, the function, you don't even have to know what it does. G of x goes negative, was it 1/3? I see 3 changes. There's a negative on the outside, a 1/3 on the outside, and a negative on the inside. Those are the 3 things you have to do. So actually, Thomas, tell me, move, resize, or flip?
It's a flip.
It's a flip. Would you call it an input flip or an output flip? Output. It's outside the parent function. That's actually why they gave you the parent function, just to make absolutely sure you know where the function is. So anything inside the radical is input. Anything outside the radical is output. So you're going to flip the output. Is output left, right, or up, down?
Maybe that's right. Right. Up, down.
Which one? Output. Which letter do you normally associate with output, X or Y?
X. I don't.
Okay. Normally, take a look up here. Look at the letter they're plugging in. The letter they plug in is X. What they normally get out is Y. X is input, Y is output. That one you need to memorize. Then once you do, you know that output is going to be up down because Y is up down. Input is left right because X is left right. Does that make sense? So you're going to flip the output, which means you flip it upside down. 1/3, Sophie, move, resize, or flip?
Resize.
Resize, because they multiply. Is it going to be the input or output?
It's output.
Output. So it's resize the output.
You should have the light figures.
And is that going to affect things left, right, or up, down? Up, down. Does output do what you expect?
Yes.
Yes, it does. So when you multiply by a third, do you expect it to get bigger or smaller?
Bigger. No. Small.
Don't read my face. Multiply something by 1/3, would you expect the answer to be big or small?
Small.
You're sounding dubious. What's 1/3 times 30? Look up here, don't whisper, don't anywhere else but me. Put this over 1, multiply. Yeah, it's 30 over 3, which is 10. Is that bigger or smaller than the original? Smaller. When you multiply something by a third, by a small fraction, it gets smaller. Is it going to do what you expect? Yes. So it's going to be smaller height, which means it's 1/3 as tall. And finally, Paul, input or output?
Input.
Move, resize, or flip?
Flip.
It is a flip on the input. What does that mean? Left, right, or up, down?
It's gonna left, right.
It's going to flip left, right. And that's exactly what you put on your paper. It flips this way. So it flip left, right. Okay? Any questions on that? Next. Yeah,
Can you do number 14?
14, let me see. Yes. So they want to get an inverse of a cube root. Let me get this over here. F of x equals the cube root of a fraction, negative x minus 3 over 2. So the key step, change this to y so you can do the flip. When you do the inverse, you trade the x and the y. So it becomes x equals the cube root of negative y minus 3 over 2. Now, how do you get rid of a cube root? To get rid of a square root, you square it. To get rid of a cube root, Grace, cube it. As long as you do it to both sides. The cube and cube root will cancel. You have x cubed equals negative y minus 3 over 2. Julia, take over. I want to go y by itself. Give me a couple steps.
We're gonna multiply by 2.
Good. So we've got 2x cubed equals negative y minus 3. Keep going.
And then add 3.
Okay. So 2x cubed plus 3 equals negative y.
And then divide by -1.
Correct. Divide by negative 1. So you should get y equals, now you could write it 2x cubed plus 3 over negative 1, but that's not simplified. What happens when you divide by negative 1? Chloe? Yeah, you make it negative. So y equals negative 2x cubed plus negative 3. There you go. Make sense? And I would replace this with f inverse. Okay. I wouldn't just call it y because the original function was y. I want to make sure you don't get them confused. You can call it y temporarily, but don't call it f of x. It's a new function altogether. It's an inverse. Yeah.
Maybe it's rest here.
Yeah, go for it. Next. Any other questions on this lovely thing? Yeah.
Can you do number 8?
8. Okay. I'll do this verbally on number 8. Notice it's still a parabola. Over 1, up 1. Over 2, up 4. Check and see if it has the right pattern. Start at the vertex. Over 1, up 1. It works. So they did not resize it. It's exactly the same size. So there's no multiplications at all. Does that make sense? If it were twice as tall, it would be over 1 up 2. If it were half as tall, it would be over 1 up a half, over 2 up 2, etc. This thing has not been resized, and it has not been flipped because it's still going up. There are only 2 moves. They moved it 1 space to the right and 3 spaces down. So moving it 1 to the right means you subtract 1 from the input, because the input always does the opposite of what you expect. Does that kind of make sense? So if you have f of x is equal to x squared, and I want to move one space to the right, left and right is input, so it's got to be inside squared. So the new thing would be x minus 1 parentheses squared. And then to move it down 3, that's output, and it does what you expect. And that does that. Next. Any others? Any of them are fair game?
16.
16. Is that big, horrendous one? It's only fair. I gave it to you. You gave it to me. Alrighty, I'm going to erase my work of art here. F of h of g of x. Can you refresh my memory on the first page? What is f of x? I erased them.
X squared plus 5x plus 2.
Okay. What is g of x, please?
2x plus 1.
2x plus 1.
Yeah.
And then h of x?
X over 5.
X over 5. Thank you. So we now f of h of g of x. This is called a double composite function. Whenever you have parentheses inside parentheses inside parentheses, do the inside stuff first. Just ignore f for now. Pretend you're looking at h and you're plugging in g of x. Just pretend f is just sitting there cooling its heels. What does h do to its inputs? It takes something and divides it by 5. Yeah. As soon as he gets back, yeah. And then it'll be g of x. Think that makes sense? It looks like a mess because there's parentheses inside parentheses. Just ignore the f for now. We're doing h of g of x, the inside. So it's going to be, what does h do? It takes the input and divides it by 5. Exactly what we're doing. I'm just writing the f so I don't forget it's there. So g is 2x plus 1. And then I put that over 5. So the first half is done. You've done h of g of x. Now I just want to take the f of that. That's a little complicated. It's something squared plus 5 times something plus 2. What's the something? That thingy there. 2x plus 1 over 5. And 2x plus 1 over 5. Here's where things start getting a little hairy. Squaring a fraction means you square the top and square the bottom. So here you go. Square the first, double the product, square the last, and don't forget to square the bottom as well, so it's over 25. Here, they multiply, the 5's cancel, and I get 2x plus 1, and then plus 2. I can simplify that, the 1 and the 2 go together, so just 2x plus 3. There's a catch though. They want a common denominator. This is over 1. I need to multiply both sides by 25 to get a common denominator. Here's what I have so far. 4x squared plus 4x plus 1 over 25. The marker is dying. Plus, and I got to multiply these by 25. So it's 50x plus 75 all over 25. Now we can add them up. It's going to be blah, 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 blah over 25. And just combine the like terms. 4x squared plus 54x plus 76. There you go. Does that make sense? Any questions on that? And what I mean is, could you recreate that one test condition? Questions? Any other questions whatsoever on any part of this thing? Okay, I want to give you one sample problem for the symmetries. And then we'll be done for today, and then the test is tomorrow. There are 5 symmetries and 5 reflections you should be able to test. Suppose you want to test for x-axis, y-axis, origin, y equals x, y equals negative x. You do need to know how to remember to do all 5 of those. The x-axis reflection is done by doing opposite y. The y-axis reflection is done by doing opposite x. Origin, opposite x and opposite y. Y equals x, you switch the x and y, which by the way gives you an inverse. And then y is negative x, you take the opposite of x and opposite y and swap them. Those are the 5 codes. Now suppose I give you a formula that looks like this. 2x squared y squared plus xy plus e over 6 x squared equals 1. I want to see if this has any symmetries at all. The way you do this, check the first, show your work. If you just say yes or no, even if it's correct, even if you get all 5 parts correct, you're probably going to lose 7 out of 10 points. Because it does say, prove your work, prove your answer for credit when the person comes. So try it. Opposite y, it looks like this. 2x squared opposite y squared. Always plug in with parentheses. Always, always, always. Plus x times negative y all over 6x squared equals 1. You need to simplify this now. The first part, the 2x squared doesn't do anything. Negative y times negative y is positive y squared. Plus, please, for the love of all that's holy, let me go down on one knee again and beg of you at the bottom of my heart, please do not write x minus y. It is not x minus y. This is not a subtraction problem. This is negative xy. X times negative y is negative xy. All over 6x squared equals 1. That's as much as we can simplify. Is that identical to the original? Verdict? There is one thing wrong. Circle your evidence and say no. There is no symmetry over the x-axis. Okay? Y-axis, let's try it. 2 negative x squared, then regular y squared, plus negative x times y, all over 6 negative x squared equals 1. Can anybody predict if this is going to work or not? Is this first term going to be good or bad? Somebody be brave. It's going to be good. Negative x times negative x fixes itself. Is this going to be good or bad? Bad. The bottom is going to be still 6x squared, which is good, but we still have an issue. Answer is no. Clear? Have about 7 more minutes. Stay with me. Origin. Distractions, probably just put them away for now. Thank you. This is 2 negative x squared, negative y squared, plus negative x, negative y, over 6 negative x squared equals 1. Peter, take this one. Simplify. First term.
2x squared, y squared.
Correct. Keep going.
Plus xy
Yes. Over.
all over 6x squared equals 1.
Is that good or bad?
Good.
Good. We have symmetry on this one. It has symmetry over the origin. Maybe see why? Can Can anybody predict what's going to happen with y equals x?
It's not gonna work.
Let me go term by term. Some terms are probably going to be good, some terms are going to be bad. John, help me out here. If I swap the x and y, is the first term going to be good or bad? Good. 2y squared x squared is identical to 2x squared y squared. What if I swap these? Good or bad? Good. X, y is the same as yx. What if I swap x with y? Bad. We now have, this last one, I'll just summarize. This is 2y squared x, well, I'll just put it here. 2y squared x squared plus yx over 6y squared. The first, you can easily fix. Commutative property says you can swap it. Second, commutative property swaps it. The bottom, you're doomed. Circle it, and that's your evidence for no. Clear? What if you do both? Prediction? What if you swap the x, swap the y, Liz? Swap the x, swap the y, and then make them negative. Or, well, switch the x, switch the y, and then swap them. Good or bad? Why? Does everybody say that if you're squaring something, putting a negative in doesn't affect things badly? And if you have two negatives, it's still fine? The negatives are not going to be the problem here. Equals 1. This is going to be fine. 2x squared y squared. This is going to be just plain old xy. And this is going to be positive, but it's positive 6y squared. And the answer is no. Clear? Think you could do that on a test? Because that's what you're going to be doing tomorrow. You're probably just going to have one problem like that. Good to go? All right, so that is it. Spend about 4 more minutes just to let your brains cool off. For those of you watching at home, thanks for watching. Click like and subscribe.